This video covers our section on modeling with quadratic equations from our chapter on growth and mathematical modeling. In this section, we're going to investigate quadratic models, quadratic equations, and how to do some of the advanced algebra with quadratic equations. Our first objective is just to use the quadratic formula to solve equations. So I want to point out first, a quadratic equation is an equation in this form, y equals ax squared plus bx plus c. And notice we have an x squared, which is the highest power of x. That's what makes it a quadratic equation. This also means that when you solve a quadratic equation, let's say of this form, ax squared plus bx plus c equals 0, you can have up to 2 possible solutions. Now, we're going to use the quadratic formula, which is given below, this negative b plus or minus the square root, etc. And notice this formula, it looks complicated, but it all involves a's, b's, and c's, which you get from the equation itself. So when you go to solve a quadratic equation, you want to make sure everything is on one side and set equal to 0. And you want to identify your a, b, and c. A is the number being multiplied by x squared, b is the number being multiplied by x, and c is the number without any x's at all. So you look at the equation, you identify your a, b, and c, then it's just a matter of plugging it into the formula and simplifying down to your 2 answers. So we're going to practice this on a couple examples. Starting here, we have the equation x squared plus 8x plus 16 equals 0. And it's probably worth taking a second to write down what is our a, what is our b, and what is our c. So a is 1 in this case. The number being multiplied by x squared, there is no number that's shown, so that means there's a 1 there. The number being multiplied by x is 8. The number without any x's is 16. So when we start our quadratic formula, it's x equals negative b, in this case will be negative 8, plus or minus the square root of, and then it's b squared, which is 8 squared, minus 4ac, so 4 times a, which is 1, times c, which is 16. All over 2a, which will be 2 times 1. Okay, so that is just plugging everything into the quadratic formula, and now it's just a matter of doing some simplification. So let's start by working under the square root. 8 squared is 64. And, oops, missed a parenthesis there. And 4 times 16 is also 64. So we get 64 minus 64, all over 2 times 1, which is 2. And notice in this case, we get negative 8 plus or minus the square root of 0 over 2. Now, square root of 0 is 0, so we get negative 8 plus or minus 0. And adding or subtracting 0 won't change the result. So we're going to end up with negative 8 over 2, which becomes negative 4. Remember, I said you can get up to 2 solutions. Sometimes you only have 1. So in this case, we got one answer, negative 4. Now, what does it mean for this to be the answer? Remember, if we're solving an equation, we're trying to find all possible values for x that make the equation true. So we're claiming that the x value of negative 4, when you plug it in this equation for x, you'll get a true statement, something like 0 equals 0. All right, so let's try this again. We have another quadratic equation. Let's identify our a, b, and c just like last time. A is 6, b is negative 1 because we have a negative x, c is negative 15. So our quadratic equation says x equals negative b. Very careful here. There's a negative from the formula, and our b also has a negative, so you want to include both of those. Plus or minus the square root of b squared. Also be careful here, it's negative 1 squared, meaning negative 1 times negative 1, so that negative is actually going to go away. Minus 4ac, so a 6, c negative 15. Okay, this whole thing is divided by 2a, which is 2 times 6. All right, so starting our simplification here, negative 1 is 1, plus or minus the square root of, like I said, negative 1 squared is positive 1. Notice here we have negative 4 times 6 times negative 15. We have a negative and a negative, so altogether it's going to be positive, so we'll go ahead and write a plus here. And then we have 4 times 6 times 15, which is 360. 2 times 6 is 12. So that is our next step. Okay, so now we're going to simplify. Obviously, underneath that square root, 1 plus 360 is 361, which is a perfect square, by the way. Let me scroll down a little bit. we get 1 plus or minus, square root of 361 is 19 over 12. Okay, so this is all the simplification we do until we deal with the plus or minus. Plus or minus literally means do both cases. So I usually like to split this off into kind of two branches. We'll do the plus case up here. That's 1 plus 19 over 2. That'll give us one of the answers. And then the minus case, 1 minus 19 over 2. Top one simplifies to 20 over 2, which is 10. That's one of our answers. Bottom simplifies to negative 18 over 2, which is a negative 9. Okay, so we have two answers, 10 and negative 9. So again, what are we claiming? We're claiming that both of these numbers will get us a solution over here. If you plug in 10 for x, you should get 0 equals 0. Plug in negative 9 for x, you should get 0 equals 0. Okay, so two quick examples of the quadratic formula. Next, we're going to talk about the graphs of a quadratic equation. And the graph of a quadratic equation we call a parabola. There's two flavors here. The blue one is a parabola opening upwards. The red one a parabola opening downwards. You know if it's opening up or down from the equation by identifying your a term and seeing if it's positive or negative. So if a is positive, it opens up. If a is negative, it opens down. Our last example, a was 6, remember? So we know if we look at the graph, it should be an example of opening up. On the parabola, the most important point is called the vertex. You can see if it opens upwards, your vertex is the minimum. If it opens downwards, your vertex is the maximum. And often, if we want to graph something like this, we want to start by finding the vertex. So how do you find the vertex? We have a little formula here called the vertex formula. It says the vertex of a parabola occurs at the x-coordinate, x equals minus b over 2a. Notice this is just the x-coordinate, so you use the formula to get your x, and then if you want the y that goes with it, you plug x into the equation and you generate the y. Now, if we want to graph a parabola, we're mainly interested in these main three things. Is it opening up or down? Pretty easy to find. Where is the vertex? So find the x and y coordinates of the vertex. And then we want to know, how does your graph interact with the x and y axis? Meaning, where does it cross the x-axis? Where does it cross the y-axis? Meaning, find the intercepts, right? Finding the y-intercept is really easy because we plug in 0 for x. We can pretty much do that in our head. Finding the x-intercepts means we have to solve the equation set equal to 0, which means we'll have to use the quadratic formula again. So let's try this out on a couple quick examples. We're going to sketch the graph of this equation, and we're going to start with, does it open up or down? Notice a in this case, let's go ahead and just identify our a, b, and c all together, just to have it. Oops. C equals negative 8. A equals negative 1. That means A is less than 0. A is negative. So that means it opens down. Right, so roughly we know it's opening downwards. Next thing we want to find is the vertex. We know the vertex occurs at x equals minus b over 2a. In this case, minus b would be minus 6 over 2a would be 2 times negative 1. So we get negative 6 over negative 2, which simplifies to positive 3. That's the x-coordinate, remember. If we want the y-coordinate, we need to plug it into the equation for x. So we have y equals negative x squared will become negative 3 squared plus 6 times x, so 6 times 3, minus 8. Negative 3 squared is negative 9 plus 6 times 3, which is 18, minus 8. Let's see, 18 minus 8 is 10. 10 times plus the negative 9 should be a positive 1. So we found the vertex, by the way, was the point 3, 1. Okay, so we know it opens up. Sorry, we know it opens down. We know the vertex is 3, 1. Next, we want to figure out the intercepts. So let's see, negative x squared plus 6x minus 8. Let me write this down one more time. Okay, this is our equation. Oops, don't want to show the graph yet. We want to find the intercepts. So for the y-intercepts, we'll do that one first, nice and easy. Remember, if you're on the y-axis, that means your x-coordinate is 0. So all you have to do is take your equation and plug in 0 for x. I'll write it, but notice we can do this in our head, because everything with an x will go away, and we'll just get y equals negative 8. So there we go. Our y-intercept is the point 0, negative 8. Clean that up a little bit. Okay, we plugged in 0 for x, so we got negative 8 for y. So that's our y-intercept. Real quick, let me make some room. To find our x-intercept, Similarly, right, we're going to have to keep in mind if you're on the x-axis, that means y is 0. And so we're going to take our equation and we're going to plug in the 0 for y. So here's our x-intercept. Going to plug in the 0 for y, and we're going to solve the equation for x. Notice, however, this is a quadratic equation, so we're going to have to use the quadratic formula. So x equals negative b, that's negative 6, plus or minus the square root of b squared is 6 squared, minus 4 times a, which is negative 1, times c, which is negative 8. All divided by 2 times a, which is negative 1. Okay, and simplify. So we have negative 6 plus or minus the square root of 6 squared is 36. This is a negative times a negative times a negative, so it's going to stay negative. And we have 4 times 8, which is 32. All over 2 times negative 1, which is a negative 2. Well, we get the square root, plus or minus. 36 minus 32 is the square root of 4, all over negative 2. And we know the square root of 4 is the same thing as 2. Keep it. Okay, so we're going to end up with negative 6 plus or minus 2 divided by 2. Negative 2, that is. Okay, so now we're ready to split into our two cases, plus and minus. We have negative 6 plus 2 over negative 2. We have negative 6 minus 2 over negative 2. Here we get negative 4 over negative 2, which simplifies to positive 2. Here we get negative 8 over negative 2, simplifies to positive 4. Now let's think about what 2 points did we find. Remember, these are 2 separate points. We found the point 2, 0, right? 2 for x, 0 for y, and we found the point 4, 0. 4 for x, 0 for y. So we're going to put this all together before I show you the graph. We know that it opens down. We know the vertex from the vertex formula. We know the y-intercept from plugging in 0 for x. We know the x-intercepts, right, 2 of them, from plugging in 0 for y and using the quadratic formula. If you put that all together, you should come up with this graph. So again, here is, where are we? Okay. Lost control. There we go. Okay. We are at the vertex here, 3, 1. Here are our x-intercepts. See why there's 2? Because we crossed the x-axis in 2 different places. And here's the y-axis. Here's the y-intercept where we cross it there. And again, we know it opens downwards. So these are kind of the main details. If you were to actually graph this by hand, you would plot all these points. Keep in mind this is the vertex, and so you know the general shape, right? And you would sketch as nice as you could by hand a smooth curve that goes through these points, hits the maximum, and then comes back down, right? We're not going to map every single point here. There's an infinite number of points, but we just want to hit the main ones, and we want to try to sketch it as cleanly and smoothly as possible. Let's do one more example of this. Running through all those details again. First, we want to know, does it open up or down? Let's identify our A, which is 1, B, negative 4, C, negative 12. A is positive, right? It's 1, so that means it opens up this time. For our vertex, we have x equals negative b over 2a. In this case, that'll be negative 4 over 2 times 1. Negative 4 is positive 4. Oops. Over 2, that becomes 2. And then remember, the vertex has an x and a y, so we're going to plug that 2 in for x, and we're going to solve for y. So replacing our x with the 2, this becomes 4 minus 8 minus 12, which that'll be minus 20. 4 minus 20 will be minus 16. So here's our vertex. We got a 2 for x and a minus 16 for y. Okay, now we're on to intercepts. I'll start with the y-intercept again. And give myself a bunch of room because I didn't give enough last time. We'll start with the y-intercept again. And remember, if you want the y-intercept, if you're on the y-axis, that means your x-coordinate is 0. So for the y-intercept here, which is the easy one, we're going to start by plugging in 0 for x. So we get y equals, let's see, it was x squared minus 4x minus 12, I believe. and everything with an x goes away, and we get y equals negative 12. So the point we just found here, our y-intercept, is 0 for x, negative 12 for y. Now for the x-intercept, again, we're going to plug in our equation. Sorry, we're going to plug in 0 for y this time. So x-intercept, we're going to set y equal to 0, and we're going to solve it for x. So again, x squared minus 4x minus 12. This is, again, where we need the quadratic formula. So x equals negative b. That'll be negative 4 plus or minus the square root of b squared, so negative 4 squared, minus 4 times a, which is 1, times c, which is negative 12. All over 2a, which in this case is 2 times 1. Okay, and simplify. Negative 4 is positive 4, plus or minus the square root of. Negative 4 squared is 16. Here we have a negative times a negative, which is a positive. 4 times 12 is 48. All over 2a, which is 2. So we get 4 plus or minus 16, 48, what is that, 50, 64, which is a nice perfect square, of course. 8 times 8. Doesn't always have to be a perfect square. If it wasn't, we'd throw it in the calculator and we get a decimal approximation, best we could get. But in this case, we get 4 plus or minus 8 over 2. We split it into our two cases, 4 plus 8 over 2, and 4 minus 8 over 2. This gives us 12 over 2, which is 6. This gives us negative 4 over 2, which is negative 2. So what 2 points did we find? I'll fit them in here real quick before we look at our graph. We plugged in 0 for y, remember? So we got 6 for x, 0 for y, 6, 0. And we got negative 2 for x, 0 for y, negative 2, 0. So there we go. That is our x and y, sorry, our two x-intercepts. Let's make this graph a little bit bigger. So we put it all together. We have our vertex, 2, negative 16. Our y-intercepts, and our x-intercepts. We know it opens upwards, so imagine if you just had these 4 points here, you know this is the base, you know it opens upwards, so you sketch a nice smooth graph through these points as best as you can. And that's how you graph quadratic equations. So lastly, we're just going to apply some of these skills to some modeling problems. Keep in mind, realistically, when we go to solve these modeling problems, they're really going to boil down to two different types of problem. One is going to ask you for a maximum or a minimum, which, because we know the shape of a parabola, the maximum or minimum will be the vertex. So look out for that. If it asks, what's the max, what's the min, you're going to find the vertex. The other thing we can end up doing is solving a quadratic equation, which requires the quadratic formula. So pretty much all of the modeling problems come down to find the vertex and or use the quadratic formula. So our first example here, it says a video goes viral on social media, and the number of views per day can be modeled with this equation. In this equation, x is standing for the number of days after the video is posted, and y is the number of views per day in thousands. According to the model, after how many days do people stop watching the video? Now, obviously, this is in the quadratic section, so we should be thinking about that. But if these problems are all mixed together, let's say like on the final exam, you look at this equation and you immediately identify you have a quadratic equation because we have an x squared. Okay, so keep that in your mind. We have to think about what type of problem, what type of model. This is a quadratic model. According to the model, after how many days? X is standing for days, so this means we're looking for an x value. After how many days do people stop watching the video? Well, this is a little slightly cryptic. Our x's are days, and y is the number of views per day in thousands. So what they're telling us is if people stop watching the video, that means our number of views per day will become 0. So what they're really asking here, and I recommend you try to boil these modeling problems down to simple x and y problems. The question here is really, what is x when y is 0? Right? How many days means what is x, and if people stop watching the video, that means the views, our y value, will be 0. So let's take our equation, plug in 0 for y. Oops, 0.125 x squared. And we're going to solve this equation for x. Now, how do you solve this equation for x? Well, it's a quadratic equation. It's set equal to 0. That means we're going to have to use the quadratic formula. Now, let's identify our a, b, and c. A is negative, I'll just 0.125. B is 1.75. Notice there is no C term, which is okay, but that means C is going to be 0. Any of these values, except for A, can be 0. So basically B and C could be 0. If A is 0, then you don't have a quadratic equation, so there's no point in doing this in the first place. But your B could be 0, your C could be 0, sometimes both of them are 0, you just have an A. That's okay, just make sure when you plug everything in, you include the proper values. So here we go, quadratic formula. Negative B will be negative 1.75 plus or minus the square root of B squared is going to be 1.75 squared minus 4 times A, I'm running out of room here, which is negative 0.125, and then times C, which is 0. All over 2A, 2 times negative 0.125. Okay, so notice 4 times A times C, this whole piece is going to become 0 because we have things being multiplied with the 0. So what we really have is negative 1.75 plus or minus the square root of 1.75 squared all over, what's 2 times 0.125, 0.25, and it's a negative 0.25. Okay. Now, if you look at this part, you're welcome to square and then take the square root, but that's kind of redundant because if you square something, but then you take the square root of it, you just get back to where you started in the first place. So this is just going to become, this whole square root value is going to become 1.75, right? We're going to square it and then take the square root again. So let's just go ahead and write it as negative 1.75 plus or minus 1.75 all over negative 0.25. Okay, we're going to split this into our two values here, and let's think about it for a second. Do we really want two answers? Were we expecting two answers? How are we going to deal with these two answers, right? Let's think about that in a second, but let's go ahead and just do our work. Here's our plus case, negative 1.75 plus 1.75 over negative 0.25. One of our answers. The other one will be negative 1.75 minus 1.75 over negative 0.25. This answer, we have the negative plus the positive version, same number. This answer is going to be 0, right? 0 on top over negative 0.25. 0 over anything is just 0. So one of our answers is 0, which is interesting. Our other answer, let's see, we add these together, we get negative 3.5 divided by negative 0.25. And this becomes 14. Okay, so what were we trying to solve for again? We were trying to figure out after how many days do people stop watching the video? So after how many days will the number of views be 0? But we got two answers. We got x equals 0 and x equals 14. Sometimes this happens with solving quadratic equations that have context. You'll get two answers, but often one of them will be nonsensical or redundant. In this case, both of these answers make sense, but one of them is redundant. You could probably guess it's the 0. So why is the 0 redundant? Well, x was standing for the number of days after the video was posted, right? So you would expect that there would be 0 views, like no one's watching the video, 0 days after it's posted, right? This is basically before it's posted, there are no views. So this is kind of our redundant answer. It's good that it showed up because it makes sense, but it's definitely not our answer. We want to know, okay, it starts at 0, then it gets all these views, and then we want to know when does it come back down to 0. So 14 is our answer. We should conclude with units at least, 14 days. Right, so after 14 days after the video is released, basically no one's watching it anymore, according to our model. Okay, so there's an example of a modeling problem where we use the quadratic formula. Let's do one more here. Assume the equation S equals, etc., models the sales of a recently released video game where X is the number of weeks after release and S is the number of sales in millions. According to this model, what are the peak sales for the game? All right, so we notice we have a quadratic equation. The question is, what are the peak sales for the game? This is another way of asking for a maximum, right? The peak sales will be the maximum sales. So if it's asking for a maximum, that means find the vertex. Let's just make a quick note here. Max means find vertex. Okay, so if we want to find the vertex, we need to use our vertex formula, minus b over 2a. Notice in our equation, b is 16 and a is negative 4. So we'll have minus 16 over 2 times negative 4, which we get minus 16 over minus 8, positive 2. So let's take a second and make sure we understand what our model does and what it's asking us. X is standing for the number of weeks after release. S is the number of sales in millions. The question was, what are the peak sales for the game? We don't want to say 2, right? We don't want to say 2 million because this is an X value. So this is actually 2 weeks. What this is telling us is that the maximum sales were 2 weeks after the release, right? It's good to know that, but it's not the question. So make sure when you do modeling problems, you answer the question. We actually want the peak sales, which means we want the S value of the vertex, which is kind of like the Y value, right? We have an X value, we plug it in, we get a Y. In this case, they're just calling it S. So we want the S value. We know the X value, so we're going to use our model. We're going to plug in 2 for X, and we're going to see what we get for S. So S equals negative 4 times X squared, which will be 2 squared, plus 16 times X, which is 2, minus 2. And then we'll just simplify this, crunch these numbers, and figure out what our sales are. So this is negative 4 times 2 squared, which is also 4. 16 times 2 is 32 minus 2. Negative 4 times 4 is negative 16. I'm just going to leave it like this for a sec. Okay, so this is what we're computing. Negative 16 and 32 will just give us 16. 16 minus 2 is 14. So we end up with 14. So what is our conclusion? The maximum sales are 2 weeks after release, and the maximum sales are 14 million. Remember, million sales. So in the second week, they had their peak sales. They sold 14 million copies of the game. And that is it. So some new stuff here, right? We talked about parabolas, quadratic equations. Our main 2 techniques there are using the quadratic formula to solve quadratic equations and using the vertex formula to find the vertex. And when we apply that to modeling, the vertex, remember, is your maximum or minimum. So if they ask you for a max or min, or in this case a peak, you know you're looking for the vertex. If they want you to solve the equation, then you're going to use the quadratic formula. All right, that's it. Hope this helps. Let me know if you have any questions, and thanks for watching.